Here is a General Electric Carry Cool air conditioner, fresh from the trash. Why you would throw one of these out is beyond me. I have never seen one rust apart. I've never seen one break. I've never even heard of one breaking. It's missing the temperature dial, but that appears to be all that's wrong with it. It's definitely set out in a couple of rainstorms. That can be cleaned up pretty easily. The grill appears to be in very nice condition with minimal to no damage. There's a couple marks. Oh, they just cleaned up. So yeah, the grill is pretty much flawless. Take a look inside. Filter's not bad. It looks like there have been attempts made to clean it, so this probably has some hours on it, but it doesn't look like much at all. These all have little documentation slots in here, which is pretty cool. Most of the time with stuff like this, the documents are long gone, but we have our document here. So let's see here. This is really interesting stuff. It's got the you've got the indoor CFM, 130 on high, 100 on low. The fan motor runs at 1,550 RPM on high and 1,250 RPM on low. I believe that these also have a power consumption related to the temperature chart. Yep, here it is. And a temperature check as well. So right now it is 75 degrees in here, so if the current sits between 4.6 and 6.3, it's working properly. This doesn't talk about the evaporator temperature, so that's probably why there's a discrepancy there. I wonder if this also accounts for, or if it accounts for dirt. Like this is the condenser plug, this is the condenser clean. That's a possibility. And then on the inside, we have a temperature split chart. So 75 degrees, it should be outputting somewhere between 52 and 43. So that's really cool data to have, so we can compare if it's actually working the way it's supposed to be. And then we have some really nice exploded diagrams here with some logic on the switches. I don't know of any other air conditioners that come with this kind of documentation. This is really neat stuff. So as is often the case, I have started to develop a fascination with these units. I used to think that these were just like, not junk, but really nothing to write home about. And I've learned that that is totally not the case. These are actually fantastic machines, extremely reliable, very well documented, easy to work on, and quite frankly borderline indestructible despite being all plastic. Here's a look at the informations tag. This one was made in January, February, March, June of 1979. It was probably sold in 1980 would be my guess, summer of 1980. The EER was really low on these, but who the heck cares if it works good and it lasts a long time, which it does. .22 gas, 12.5 ounces, and then oil 220 cc. I'm not sure what that means. Made in USA. Model number AT805LAL2. So this is This is being taped in 2025, so let's see, 1990, 2000. This is 46 years old. This is old. It's kind of interesting. It looks really cool with or without the cover on, because then you can see the fan. Let's take a look on the back. I've never actually had one of these apart. I'm very curious to do a teardown on this to see what it looks like inside. I mean, I've seen pictures and videos, but never actually worked on one myself. So let me get the drop light out, because we're not gonna. Actually, I'll just use this lamp. Drop light's upstairs. The lamp is consuming 12.4 of the watts, 0.17 the amps, so the power factor is 0.61. This CFL has a garbage power factor. I want to see if we can take a peek in here and find out if it's dirty in there or not. I don't think it's going to be. I think that this is a very low hours unit. The logo is in very good condition, so that's cool. I don't know what kind of plastic these were comprised of, but it doesn't seem like it's particularly susceptible to sun damage. There definitely is some, but it's, 45 years of sun damage. No, definitely not. Doesn't look like it anyways. Oh, it looks pretty clean in there. I can't really see much, but generally pretty clean. And I believe that these do have factory drain holes. I think that's it right there. I'm almost completely certain that these have drain holes, because there's no, as far as I know it, there's no slinger. And I want to point out something very interesting that I think is very interesting anyways, and I haven't heard this discussed before, but these have no slingers and the EER is still 7.5. There's a lot of machines with the same EER that have the slinger. Really makes you wonder. Yeah, that is definitely a drain hole right there. I'm not sure what this is. I wonder if that's like some kind of adjustment to sit on the windowsill or something. But yeah, there's the drain hole right there. So that is definitely one of the reasons why these don't rust out. No part of the coil sits in water. Now, granted, when it rains, this is all going to get wet, but then it's going to dry right out, especially if it's being used. So that's pretty cool. Only drawback to these is that they seem like they're kind of loud. This year I'm hoping to actually use some in the window. I've never tested one of these in the window before, so it's possible that a lot of the fan noise is from the outside. I don't think that these are lightweight at all. I think these are very heavy for the capacity, in fact. I don't know why this type of fan was used. I feel like this could have been a lot quieter if a blower wheel was used. I suppose we could potentially put different types of filters in here and potentially block more of the sound, if it does seem to be particularly noisy. You know what I'm intrigued by is how the heck does the water channel work in this thing, because the coil is all up here. It comes up to here, all the way forward. Does it just drip in the fan? Like, how the heck does that work? I don't know. I'm very intrigued to take one of these apart and have a look inside. Let's start it with the cover off first. I'm curious if the cover makes it any quieter. It probably makes it considerably quieter. We should be in range. It's 75 in here. Yep, it just clicked off, so it's out of range. This does have fan only settings, so we can test it that way. Alright, so I believe that these are shaded pole motored fans. Oh no, it's not. It's PSC. Also something inside there. So that is 0.68 to amps, 76 to watts, power factor of 0.97. And it does in fact seem like the majority of the noise is from the back. Definitely seems to be the case. In fact, this actually seems very quiet. That I should really have just thrown this in the window as opposed to doing this nonsense, but if we do this, it kind of blocks off some of the noise. Yeah, I actually think that this might be kind of quiet. I've also been told that these dehumidify very well, which would make sense because they work more off of temperature than airflow. The airflow goes over the coil pretty slowly. Yeah, it's not a very strong output. It's more strong over here, I guess, because the coil probably runs like this and then it goes down. So this side collects all that air from the side. Very interesting. Let's try the high. That sounds like almost all the noise is on the outside. I can hardly hear any noise on the inside at all. Actually got pretty good airflow on the outside. Can't really tell because it seems like all the noise is on the outside anyways. Oh, let me grab this chart out. I'm not going to put that on all the way because it's difficult to get off. Well, it's almost 11 o'clock, but I might just have to throw this in the window upstairs just for the curiosity of it, just for a couple minutes to see, because it's still warm out, and that's rare this time of year for it to be warm enough to use air conditioner. Okay, I think I'm going to find that this is a very pleasant surprise of a unit. Let's go ahead and start up the compressor. I don't know if it works. I don't see any reason why it wouldn't. Well, let's see, here we go. I hear gas in there, and no doubt that it works. Now we're having some trouble with the temperature apparatus here. In fact, I left all the batteries upstairs. I'm going to go grab some batteries. That's cool. It's cooling. It's not as cold as it should be yet. But we're getting there. I used to have 4 of these batteries. I'm down to 2. I don't know where the other 2 are. And I think both of these are out of charge. So I'll see if we can get some readings out of this thing, but we might not be able to. Okay, this is working. It's making a fool out of me. It even says the battery is full. Like it's capped. Alright, 75 on this thing. I just touched the probe, that's why it went up. My thermometer over there says 75. This is saying 75, so it's comparable. Let's stick this in here and see what we get. I want to make sure that this does not actually touch the coil though, because that'll skew the readings. I just want it to be kind of right on top of the register. Okay. So according to this, at 75 degrees, the current should be between 4.6 and 6.3 amps. It's 4.3, so it's probably not up to charge yet. Give it a few more minutes to build more pressure. The temperature should be at highest 52. At best 43. We're getting very close to being in that range. It just needs a few more minutes to build head pressure. I really just don't understand why you would throw this out. This is so much better than any of the units sold today. This lasts longer. It cools better, it's more reliable, it's easier to work on. Power draw is still climbing, so it's still building head pressure. It's 48 now. So this says it could potentially go all the way down to 43. It's quickly getting there. This has good airflow all around the condenser area. I think it's a pretty low hours unit. That's nice and hot. Metal? Hope so. Yeah, it is. Okay, there we go. We just hit 43. So it's working at the best spec it says it should. And the power consumption, it's allowed to go up to 6.3 under these conditions. The minimum is 4.6. It's at 4.9, so it's very close to the minimum. I would say the condenser is perfectly clean. Temperature, yeah, lowest is 43, and it's sitting right around 43. So it's working about optimally according to the documentation. Alright, so it's sitting right at 43. Doesn't seem to be going any lower than that. 5.16. That's towards the lower end of the range of what it's allowed to draw. It's working perfectly. Sounds nice. Well, I wouldn't say like a nice, really nice compressor. It sounds healthy. Sounds the way it's supposed to, given the kind of compressor it has. Actually, I think these have some kind of a weird variant of a rotary. I don't think it's a standard style compressor. It sounds different than it usually does. It sounds interesting. Definitely not a reciprocating compressor. It's a little chattery like the standard rotary would be, but not crazy. Alright, so that's low. Let's go to high. Temperature didn't change much at all, maybe 2 degrees tops. Still very cold. I like this machine. It's even better that it was saved from the trash for free. That's 5.52 on high amps, 644 the watts, power factor 0.98. So that capacitor, I'm sure it's original. It's 46 years old and it still works perfectly. The discharge must be on the other side. It's cooler on this side. Experiencing a pretty considerable temperature difference. Right where the data sheet says, on the nose. Quality stuff. A quality we will probably never see again. So stop throwing these things out because you can't replace them. Actually, the noise will be up here. Awesome piece of machinery. Looks great, works great, lasts a long time. What else can you ask for? Well, we could ask for the video to be straight. And there we go.